Hello, in this video I will tell you about my work on the Hight Cryptology algorithm. The Hight cipher is an 8-branch generalized physical network. The picture shows the block diagram of encryption stage of the Hight cipher. The cipher operates on a 64-bit block of plain text and 128-bit master key and produces 64-bit ciphertext. The encryption stage of Hight consists of an initial transformation, (32 rounds of transformations), and a final transformation. Each round of the 32 rounds mainly consists of simple operations that are mod 2/8 additions, bitwise rotations, and explosive OR. The case scheduling consists of two parts: widening case generation and subcase generation. The widening keys are used in the initial and final transformation, where 4 widening keys are used in each transformation. The subkeys that used in the 32 rounds of transformation are generated by taking the mod 2/8 addition of the master key and the pseudo-random generated constants. To be specific, 128 subkeys are being generated. 4 subkeys are used in each of the 32 rounds. Throughout the video, I will try to add some txt files to the empty file named verify using C, Matlab, VHDL and Questa Sim. Here, I wanted to show you the C program that I wrote to produce the plain and master keys mixed together and store them in a txt file. As I mentioned in the video, I adjust the production parametrically to change it whenever I want. As you can see, 3 txt files were created in the verif file, and they were created as files representing plain and master keys. In order to verify the Hight Cryptology algorithm, I made the program in the C and read the files I created randomly before and wrote the results to the C results txt files. I created the C program to put the txt file in the verif file again. While I was writing the C program, I wrote the program step by step and compared the accuracy of my results with a MATLAB program that I had previously found. In order to make the program more effective, I made use of functions operations, and I wrote regular C code. I printed each output of my C program in this way on the terminal screen, and I followed the steps made in the C program for each result I produced. As you can see here, a cresult.txt file has been generated. This file keeps the results after the given plain and master case are subjected to the Hight Cryptology algorithm. In this part of the video, I will talk about the VHDL codes I wrote. While writing the codes, I used Questa Sim as a simulation medium and analyzed the wave images of my results through this program. You can see the VHDL codes I wrote in order to write the VHDL results from the files I selected. I would like to thank YONGATEK for the data dumper and data injector files that YONGATEK shared with me in order to be able to do the filing process here. Here I wanted to show you the VHDL files that I wrote via Notepad program. As I mentioned earlier, I wrote the program in 32 steps using the finite state machine because the Hight Cryptology algorithm consists of 32 steps. As you can see, the VHDL results.txt file came after running Questa Sim. As I mentioned earlier, I wrote the C program to perform the verification process, and here I compared my VHDL and C results. As you can see, the results have been obtained correctly. Now, I will share with you the other transaction I have done. I installed the program on the Basis 3 card and using MATLAB, I communicated my Basis 3 card and my computer over the UART protocol. I wanted to show you the UART VHDL files I wrote over Notepad. At this part of the video, I run the MATLAB program and I am waiting for the results to be printed in the txt file. The program runs a little slow, but it is important to me that it works correctly, not slow. While MATLAB program is working, I would like to explain how MATLAB code works by using block diagram. First of all, I read my plain and master case, which I created with the C program using MATLAB. Then I send every information I read to the Basis 3 card with UART. And after doing the Hight Cryptology operation on the Basis 3 card, I send it to MATLAB using UART. I compare the results from the Basis 3 card with the information I read from the MATLAB and VHDL results txt file, and if the results are the same, I write to the UART results txt file. I do the results through a loop and do the UART operation until it is correct. The program works like this to the end and places the txt file into the verif file. As you can see in my UART result txt file inside the verif file. Now I am comparing the results of these files. As you can see, all my results are correct. It was like this in another of my work in the field of cryptology. Thank you for watching and listening to me.